Yeah, I mean, you could say like if you and The Rock and Taylor Swift were like you met up with each other and you decided to like climb a mountain,
Okay.
and you knew that like no one was going to believe that you climbed a mountain with The Rock and Taylor Swift, but at the top of the mountain, you took a photo of yourselves reaching the summit of this mountain. And let's say for the sake of argument, it's like a very special camera that like anyone can verify that it's not photoshopped and that there's no way for you to like fake this photo, but you get a proof that that you in fact climbed a mountain with The Rock and Taylor Swift. And this is not like for all the cryptographers that may or may not be listening to this, this is not like a mathematically precise analogy. They're like different properties, but it sort of like gives an intuition about like people don't need to like watch you like take each step up this mountain. They need like a succinct proof that in fact you did something and this was the result.
Welcome to the Never Die Podcast, your ultimate source of crypto alpha for those who never quit. Today we're talking to Brendan Farmer, co-founder of Polygon, an absolute legend and one of the foremost knowledgeable people when it comes to ZK on the planet, or ZK, you could all say zero knowledge, because that's what ZK means. It has been hailed, ZK, as one of the most revolutionary leaps forward in cryptography since the invention of the blockchain. And in this episode, we're going to talk about what even is ZK. Nobody seems to know. Everyone pretends like they know on Twitter, but nobody seems to actually know what ZK is. But in this episode, we break it down so simple that even your mom will probably understand how it works, as well as we dive into the use cases of ZK, the differences between ZK rollups and optimistic rollups, and why so many people believe that ZK is the future. And after this episode, I also believe ZK is the future. And I'm like, oh, why would anyone want to build an optimistic rollup at this point? Polygon's aggregation layer and how it uses ZK to essentially build crypto's version of the internet. That's not overhyped. That's almost me underhyping it, because it actually is that cool. As well as we talk about a ton more things. Let's dive in. Can you give me maybe a super simple explanation of what is ZK? Like so simple that if my mom was listening, she'd be like, oh, I get it.
Yeah. So I would say it's this cryptographic. Well, I probably shouldn't even say that. I would say it's like this mathematical technique that allows us to take some computation, some program, and we can prove that the execution of the program resulted in some output without like forcing anyone to run the program. And so if we think about it in the crypto context, that program can be like a huge number of Ethereum transactions. So it could be like 1 million Ethereum transactions. And I can prove to you that the output of running all of those Ethereum transactions was some value with just like a tiny proof. You don't have to download and rerun all those transactions. You don't have to like individually execute each one. You can just verify this tiny proof and then look at the output and say, okay, I can trust that this output was the result of executing all of those transactions in a valid way.
Does
that kind of get there?
I think so. So would a good analogy be like obviously this is like really high level, super abstract analogy, but imagine like I went and spent a whole day hanging out with The Rock and Taylor Swift, and we did all these incredible things that are like mind blowing, like just all this fun stuff. And maybe a ZK would be like a way to prove, again, really abstract, but like the concept is I could prove, I couldn't really prove this, but I could prove that, we did all those things without you having to go and experience that full day.
Yeah. I mean, you could say like, if you and The Rock and Taylor Swift were like you met up with each other and you decided to like climb a mountain, and you knew that like no one was going to believe that you climbed a mountain with The Rock and Taylor Swift, but at the top of the mountain, you took a photo of yourselves reaching the summit of this mountain. And let's say for the sake of argument, it's like a very special camera that like anyone can verify that it's not photoshopped and that there's no way for you to like fake this photo, but you get a proof that that you in fact climbed a mountain with the rock and Taylor Swift. And this is not like for all the cryptographers that may or may not be listening to this is not like a mathematically precise analogy. No. There are like different properties, but it sort of like gives an intuition about like people don't need to like watch you like take each step up this mountain. They need like a succinct proof that in fact you did something and this was
and the idea is, okay, obviously if you had to come and like witness this and you had to climb this mountain with us, it's going to take a lot of time. It might take some money. That's going to take a lot of energy, and that's really hard to do. Where if I hand you this photo, that's a couple seconds, a lot less work, a lot less time, a lot less money, and now you get the same result. Like you can prove, hey, this thing happened. Now that's a very vague and abstract analogy. Like you mentioned, it's not mathematically precise, but it gives the average person an idea of like, okay, you can prove this thing happened with a lot less work and time and energy and money or whatever. Using something like ZK. Can you give me like maybe a practical example of what's like a thing that ZK could enable? Like a simple example?
Yeah, sure. So I think that you're right. Like you get the same amount of clout regardless, but the person doesn't need to like spend all the time and the money to like actually physically verify that you did something. But yeah, so like the way that I would think about the applications of ZK, they basically fall into two categories. There's privacy and then there's scalability. And so in the privacy case, you might have a desire to like remain anonymous, even as you transact on a public ledger. And so a zero knowledge proof allows you to say like, okay, like I own these coins or these tokens and I've spent them. I'm not going to tell you like which coins I'm spending or like who I'm sending them to or the amount or anything that would compromise my privacy. But I'm going to prove to you that in fact the coins exist, that they were unspent. And so we still get to like respect the rules of the ledger. And so I think that's like on the privacy side, being able to do things anonymously and to be able to like execute computations that are private, I think is like a really important application of zero knowledge proofs in the long run. On the scalability side, it's sort of like what I was describing earlier, where like right now we have this problem where like computation is sort of bottlenecked on Ethereum, and we limit the number of transactions that are able to be processed on L1 because like we don't want the state to grow too big, or we don't want to put like put super onerous requirements on people running validators. And so the idea is like, okay, let's move the processing of those transactions off of L1, and let's let users deposit funds into what we call an L2, and then the transactions that those users perform will be processed by some other operator who's operating the L2. But that operator will always be constrained by the fact that they need to provide a zero knowledge proof back to L1 to like settle the state of the L2. So they can't like create an invalid transaction or steal everyone's funds or like do anything that would harm users because they are constrained to only behave in valid ways by the proof, because they can't generate a proof for a transaction where they're like minting 1,000 ETH to steal everyone's funds.
Okay. So to dive into the first use case you mentioned, privacy, I think that's a really easy one for me to understand. Okay. So just like in our analogy, again, vague, you might not know the conversations we had on that mountain. You might not know particularly where that mountain was or like certain details of that event, but I can still prove the thing I need to prove, which is that the event happened. And so with privacy, like you mentioned, you might not know the tokens I'm trading, the amount I traded, the amount I hold, but these things but you can prove the important thing you need to prove for whatever that transaction is. Now, when it comes to the other one, the scalability, that one I did get a little bit lost on.
The way that I would think about it is like, okay, you don't want to pay $100 to swap like ETH to USDC. Not that you would ever sell your ETH or do anything so stupid as to sell ETH. But so instead, what we can do is we can like have this other chain where maybe the validator requirements are much higher, and so it's processing a ton more transactions. It has more capacity, and so fees are lower. And so you could take your ETH and you could deposit it, or you could like onboard from an exchange, or there's some way to like get your funds onto that L2. And so that L2 is like processing transactions. But let's say that it doesn't have zero knowledge proofs. Let's say that it's just a sidechain. And so basically the way it works is like the operator is processing a bunch of transactions, and periodically, if users want to leave that L2 and take their funds back to L1, then the operator basically just provides like a signature saying, okay, here's the latest state of the chain. Here are all of the people that are withdrawing their funds from this sidechain and are going back to L1. And so you say, great, I'm going to swap my ETH. I might do a bunch of other stuff. And then I'm going to like take my funds back to L1. And so the problem is that this chain is only secured by like the assumption that the validator will behave honestly. Because let's say like the validator decides that there's maybe like $1 billion worth of ETH on this chain, and he would actually prefer to steal everyone's ETH versus continue to run the chain. And so he creates this transaction, and it's not a valid transaction. It's just like, I'm going to mint a bunch of ETH on this chain, and I'm going to send it all to my address as the operator of this chain. And that's going to allow me to, before anyone else can withdraw their funds, I'm going to withdraw all of the funds that are locked in the bridge on L1, and I'm going to basically rug this sidechain. And so this is a really bad outcome, because it means that everyone that has been trusting the operator of this sidechain to behave honestly and to process their transactions instead finds that all of their funds have been stolen from them. And so I think that the way that you can think about it is, this is where zero knowledge proofs come in. Zero knowledge proofs like allow us to not have to trust that the operator will not steal our funds, because the operator of that chain must provide a zero knowledge proof that all the transactions that he's been processing are valid before he can withdraw any funds, or anyone can withdraw any funds from the bridge on L1. And so like, again, you can think of like, there's L1, there's this bridge contract, and users deposit all their funds into the bridge contract, and then they get those funds on the L2. And likewise, when they're coming back, they can they burn or they deposit funds in the L2, and they're able to withdraw back on L1. And so the zero knowledge proof just like constrains the operator from being able to process invalid transactions that would jeopardize user funds, because there's no way to generate a zero knowledge proof for a transaction that would like mint 1 million ETH out of thin air. Those transactions are against the rules of the EVM, and the zero knowledge proof checks that the rules of the EVM are being followed.
Got it. Okay, so to kind of summarize what you're saying, it's that without the zero knowledge proof, they would withdraw the funds. There's no one checking them. There's no one keeping them accountable. The zero knowledge proof is a step that keeps them accountable. So they could input, hey, withdraw all the money to my address, but they couldn't prove it. And so they couldn't prove that they're following the rules, and so it would never be able to go through. And so it's almost like this shield on user funds, like not making sure it's constrained to a certain subset of rules. But how does that allow it to scale? That's the part I'm not understanding.
Yeah, exactly. So now instead of because we have this trust and security guarantee, now instead of like relying on all the Ethereum validators to process transactions, we can spin up like a bunch of different L2s, and maybe like the L2s are going to be run by people with like really high hardware requirements. So we have like a lot more capacity in those chains. They could be run by a single operator, and so we can exploit centralization and parallelization much more than if we were just running. We can process like 10 or 15 TPS on Ethereum, but maybe each of these L2s can process like 100 or 500 or 1,000 TPS. And we can basically add these L2s as we need to meet demand. So it's a model where like instead of capacity being like super limited, we can always add capacity as we need it to keep fees down.
Okay. Now I think I understand what you're saying. So with like Ethereum, the L1, like there is no trust. There's no like central party you have to trust. So there is no need for like a prover because it's just code you're trusting. But when you go to this L2 model that you're talking about, like you can now introduce like these like sort of like centralized entities. But these centralized entities have their hands tied. They can't do anything wrong, but they can process things a lot quicker, a lot cheaper, obviously, because you're not having to have all this coordination happening. And when you introduce these proofs, it constrains them from doing anything bad. They're still just as like trustless in a sense, but you're able to take things off of the blockchain and process them that way to make things faster and cheaper.
Yeah, I think that's a good way to look at it.
Okay. That makes a lot of sense to me now. Okay, so let's kind of follow this same kind of thought process. How does that end up? How does ZK incorporate with what Polygon's doing with the AG layer?
Yeah, exactly. So the idea is like remember how we said, okay, we're going to scale by adding a bunch of these L2s, and the problem is like as we're adding L2s, we're also introducing fragmentation. So now like a user might be able to onboard to one of these L2s and get like low transaction fees on that L2, or they might be able to do something. But let's say that they have their funds on one L2 and they've just swapped from ETH to USDC, or they've just done some DeFi thing. And now they want to play a game, or now they want to like do some social application or something. And that requires them to get to another L2. And right now, if you think about what's required to do that trustlessly, it's, okay, I need to send a withdrawal transaction to the L2 that I'm on. And then that L2 needs to generate a proof that proves that my withdrawal is in fact valid, so I can withdraw back to Ethereum. That proof needs to be verified on Ethereum. And the block containing that verification needs to be finalized on Ethereum. And then I need to deposit to a new L2. And that deposit transaction needs to be finalized on Ethereum. And so all in, this takes like 40 to 50 minutes for me to like do a simple transaction from one L2 to another L2. And so the AG layer is basically a solution to this problem where we have horrible UX and we have fragmentation across a bunch of different L2s. And so instead, we can use the AG layer to trustlessly do cross-chain transactions in under a second. And the AG layer allows us to like maintain fungibility of assets. So I can take like my ETH that's on one L2 and I can immediately get ETH that's on another L2 to like play a game or to mint an NFT or to do, whatever I want to do within the Polygon ecosystem. But the goal is to provide unified liquidity and unified state. And that means like having super low latency cross-chain transactions that are still safe. Like we still get these strong Ethereum security guarantees, and also have like asset fungibility and the ability to like instantly read state from other chains. And so that's fundamentally the problem that the AG layer is trying to solve.
So just to recap that, so the AG layer basically enables the ability to move between chains that are built on the AG layer, like final in destination for the user. It means you can essentially bridge between chains within seconds. You might not even know you're bridging. You're just like, you might just do a transaction on Polygon ZK EVM, and it might loop into OKX's X1 exchange, do something over there, and it comes back and it's all settled on ZK EVM or wherever you want it, right? Like it's just like almost internet of blockchains is almost like the concept of like you're just moving between web pages now. There's not all this friction of like having to bridge between blockchains, and there's all the kinds of cool use cases you can use because like you have hyper specialized blockchains where maybe one's a privacy blockchain and another is like a super fast, super cheap blockchain. And what can you do when you like kind of, can use all these things seamlessly together, and what kind of weird things can you make? And that's kind of the vision for the ag layer. And then you also mentioned unified liquidity. That's a big deal. Blockchains, liquidity is like their lifeblood. And so, when you start a whole new L2 and you have to start from scratch, you have zero liquidity on it. That's really, really hard. But how cool would it be if you just, I'm going to plug this blockchain into the ag layer. Oh, cool. Now I have access to $100 billion of liquidity that can just move seamlessly into my chain if I have something useful. And so it's a really, really cool concept. And that's supposed to be, from my understanding, realized by the end of this year, that's amazing. What I'm wondering is how does ZK fit into how the ag layer works? That's the part I'm not quite understanding.
Yeah, so ZK allows us to enforce the rules that basically provide a safety guarantee for all the chains that are using the ag layer. And so if you think about what's required to do low latency cross-chain interaction, and I really like your analogy to the internet. Like the way that we think about it is like on the internet, you can just go to a website. You don't need to route your packet through different zones, and let's say that your website is hosted in Europe and you're browsing from North America. You don't need to bridge your packet across the Atlantic Ocean to get to that website. You just know that the website exists in a unified environment that's accessible by everyone. And so I think that that's a really important analogy for what we're trying to build with the ag layer is there might be an application that's on some chain, but users don't care. Users don't even have a notion of what chains are, of how they need to bridge to access that application. They can just seamlessly get there. I think that's a really powerful concept that doesn't currently exist in crypto. But yeah, so getting back to why ZK is important for this vision, in order to do this safely, chains need to guarantee that they're not going to be rugged by a misbehaving operator of another chain, because this whole system is permissionless. Anyone can create a chain, any builder can join the ecosystem. And so if I'm chain A and some user on my chain is sending a message to you and you're operating chain B, you need to know that that the state of my chain that you're relying on is not going to change before we all get finalized to Ethereum. And moreover, that the state of my chain is valid. You're not, depending on some message where someone minted 1 million ETH out of thin air, and the bridge is going to become under collateralized. And so ZK allows us to enforce these restrictions, so that by the time we settle to Ethereum, we have a proof that every chain in the ecosystem behaved in a way that is consistent and according to the rules of the ecosystem. And so that's a really, really important guarantee. And it's something that you can't, I know we haven't spoken about optimistic rollups, which are sort of the competing architecture for how you do L2s. But there's this really important downside to optimistic rollups, which is they need this long period where anyone can challenge an invalid transaction in an optimistic rollup. And so you can't have immediate finality as soon as a proof is generated, because you need to maintain the ability for someone to challenge the claimed state of an optimistic rollup if it depends on an invalid transaction. And so you can't that creates I think a very negative experience for users, because they can't use the native bridge to quickly withdraw or move assets between chains. And if you think about it from a capital and efficiency perspective, if you're holding a highly volatile asset, like most people who use cryptocurrencies are, the downside of having your funds locked for 7 days is completely unacceptable. And so what happens is, in the optimistic rollup case, you use third-party bridges. So you'll put your funds, you'll deposit your funds into some third-party contract on the L2, and that bridge will basically work with liquidity providers to get you your funds back on L1 or on some destination chain. But this isn't good for users for two reasons. First, it's expensive. So if you look at like the total amount that's been spent on third-party bridging to avoid the 7-day withdrawal delay on Arbitrum, it's like $40 million worth of ETH at today's prices. And so that's like a crazy amount of money in aggregate that's being charged to users. And the second point is that it's not trustless. So we've seen like over and over again, there are bridge hacks and there are instances in which user funds are stolen from bridges because they aren't providing this a guarantee that's like secured by zero knowledge proofs or even by fraud proofs. And so when we think about the ag layer, like ZK is a hugely important component that allows us to build the ag layer and to provide the guarantees that we're able to.
Okay. I think I understand it. So just like you had the central entities last time and you had this like ag layer, or sorry, you had the ZK and it's like kind of watching, making sure they're not doing anything bad. And if they do anything bad, it can't pass. It's like a little RoboCop guard robot that's like, in real time watching everything and nothing can pass. It's like Gandalf. And it's like, you shall not pass if you break the rules. Right. And so, But and so that's how it works. Except for instead of being these central entities, the central entities is replaced with these blockchains. So the blockchains have the rules. The rules are like tied into everything. And then if anyone tries to break the rules, they can't pass this ZK proof. It's like no, you're gonna turn back because I'm the ZK proof and you're not passing. And so that's how you're able to get everyone to like in real time honor the rules. Optimistic rollups are different. They're like a big old. I mean, in my head, I was kind of like picturing a pit, but like you have this big old pit where like all the things that have happened over the last 7 days, they sit there and anyone could come to this pit and look down and say, okay. Oh, that's wrong. And they could hit a button and they hit that button and that makes everything, I don't know how it gets fixed, but somebody's got to come fix this because, everyone's got 7 days to come look in this pit and make sure everything is up to speed. And where ZK is different. It's real time. In real time, everything kind of passing through. Anything that breaks the rules, you got little robot Jarvis here, and he's like, nope, that breaks the rules. Can't do that. I'm literally not going to let that pass. That's maybe like a really, really abstract. It's probably making you cringe, but like an abstract, high level analogy of the differences. Is that a good one?
Yeah, so I think that makes sense. I might change from like a pit to like when you come back in the US
Yes.
and you're just like waiting in line at customs
Yes.
for like 30 minutes at a big airport. It's basically like that where like your funds in an optimistic rollup are just like sitting there waiting to be allowed entrance into like to an L1 or to like another L2. And at any point, like someone can pull someone out of the line if it's an invalid transaction, but everyone needs to wait to like actually be able to leave or to enter the country. And I think ZK is much more like you have you seen those like the fast pass or global entry? I can never be bothered to like sign up for this. And so I always have to wait in line, but like, it's like, okay, like you have this certificate or you have this proof that allows people to like quickly verify that you're a valid transaction. And so you can just like breeze through this line because you just show like positive proof that that you are who you say you are, that you're sort of like a valid transaction in this model. Whereas in the optimistic case, you have to wait in line for 7 days and you have to rely on people that are basically like, scrutinizing every person to see if they are a criminal or if they're like, not supposed to be there. And so that's the big difference is like in the one case, you're providing positive proof that you are a valid transaction. And that allows you to like immediately get through this bridge or to like enter or exit this L2 environment. Whereas in the other case, you have to wait in line.
Okay. I like this analogy. I would say though, from my understanding, wouldn't it be more that like maybe for optimistic, it's more like a room because there is no really security necessarily because it's just the people go in the room, they have to wait there for 7 days. And there's not anyone necessarily assigned to go over there and like check them out. It's just anyone can show up. Wouldn't that be right? Anyone can show up and
yeah. Yeah, exactly. So there's no. I think that's a good point. There's no there is sort of like the verifier's dilemma because you don't know actually, and this actually I think is a really important point in the world in which you have like 1,000 optimistic rollups, but you don't know that someone's actually scrutinizing all of these transactions to determine if like a fraud has occurred. You just sort of hope that there will be like interested parties that are able to like run validators for these chains and will be able to detect fraud. But I think that's an important point. Like there's no one that is sort of like actually scrutinizing for bad behavior. It's just you assume that there are so many people in the world that are like interested in doing so that at least one of them is able to do that and to submit fraud proofs.
Okay. So the optimistic, you're optimistic. That's why it's called optimistic. You have a big glass building. Anyone could come to the glass building, look inside. They see something wrong. They hit the button. It goes. But there's actually no security. There's no like border security that they have to actually go through. It's just, again, anyone can come in and report and say, hey, that person doesn't look like they should come in the country. Where ZK is actually, there's a very efficient border security. Everyone has passes. Anyone that doesn't have the pass can't come through. And so it's just constant moving line. You don't have to wait for 7 days. You're coming through the border. If you got the pass, you don't got the pass, you're not let in. That would be like maybe the main difference between the two.
And I hope no one thinks that we're like getting into like immigration politics or
No, we're not. But it's a really apt analogy because like I didn't understand it before, and now I feel like okay, I understand this concept. Maybe to go further, then what? You said privacy, you said scaling, but I know like I've heard people say that there's all kinds of things that ZK unlocks from like identity to you don't have to give your social security number when you file your taxes, like just really simple things even outside the blockchain. Could you give some examples of things that maybe you've heard that ZK unlocks and maybe what you're excited about over the next 10 years that ZK is going to enable, whether blockchain related or not?
Yeah, sure. So I think, like you said, there's this whole class of applications that where it's like privacy, but not for anonymous cryptocurrency transactions. I think that these are interesting. The like canonical example is like when you are trying to get into a bar, you're showing your ID to the bouncer, and your ID has like your name, it has your address on it, it has your date of birth. But really, like the only thing that you're trying to prove to the bouncer is that you're over 21 in the US. And so the idea is like with a zero knowledge proof, you could basically like provide this, like provide a picture and provide a proof that you're in fact over 18, over 21. And the bouncer could use that to verify instead. I think that these applications are tricky because they rely on like issuing authorities that you have to trust. And like, I think it's difficult to sort of convince the US government or like state governments to opt into issuing credentials with zero knowledge proofs. But I think that they like in the long term, there are interesting applications. Like you said, like you could prove that you have done your taxes correctly, and that you are required to pay like X amount without actually revealing a ton of things about your income or sort of like what you're doing, and so like I think it does sort of change the trade-off space for like privacy, while at the same time like not giving up integrity, because you're still like proving that you behaved in a valid way, just like in the private cryptocurrency example. You're proving that you respected the rules of the ledger, but you're not revealing like exactly what you did. And so I think like privacy is important, and I think as a technology, it's really interesting to think about ways in which like it could change things that societally we sort of take for granted. But I do think it's important not to overhype and to recognize that like in order for zero knowledge proofs to occupy this role in society, it requires like a lot of buy-in from like the parties that are basically verifying the underlying data that's used in the zero knowledge proof.
What about something like, I've heard a lot about ZK and AI. Like we have all these deep fakes coming out and they're getting worse and worse. And they're probably going to get really, really bad over the next 5 years. Like I imagine over the next 5 years, you're going to struggle to know what is real and what is fake. And I've heard like concepts of like, oh, cool, we could use ZK proofs to like prove like this is a real photo versus this is not a real photo. And I imagine you'd almost have to have a social media network that's like, hey, they have to have the guardrails they have to have the rules set so that they use ZK. And then you'd probably on the other end with something like Apple have to have something on your cell phone that says, hey, this is authentic photo. But if, are there use cases you see where that might be something people do, or do you think that's mostly just kind of like hype?
No, I think it's interesting. So the photo example is like basically the concept is, okay, we have a camera, whether it's on your phone or some other special camera, and it has like a trusted enclave where every time you take a photo, that enclave signs the photo to attest that it was actually taken from a real camera. And so the problem is like, if you change one pixel in that photo, suddenly the signature is not going to verify because the photo has changed from what you signed, from what the TEE signed. And so the idea is like, we could say, okay, there are some accepted changes that we can make to that photo. Like maybe we can apply a filter, or we can do things that like don't make it a deep fake, but might make it a better photo. Like maybe we could like crop it, or we could like change the contrast or the brightness or something. And so the idea with ZKML is we can verify that the changes that we made to the original photo that we have a signature for are valid and don't constitute a deepfake. And so I can hand you the edited photo and a zero knowledge proof, and you can verify like, okay, there was some original photo that was taken from like using a camera that has this special chip that only signs, real photos. And then there were some edits made, but they were like minor. They didn't change sort of like the content of the photo in a meaningful way. And so I can trust this photo, that this photo is real and that it's not doctored. And so, yeah, I mean, I think it's like really interesting. It does depend on that chip in your camera not being subverted. And so that's like a tricky thing because these trusted execution environments like have sort of a checkered history as far as not being compromised. But I certainly I agree with you on the proliferation of deepfakes, and I think that it's certainly like a decent solution to that problem.
Okay, yeah, because somebody's going to have to come up with a solution. And that sounds like it could potentially be the route out. And I could imagine a world, especially in 5 years, when literally nobody can tell what's real. And you have court cases where you can't use a video or a photo as like evidence because you literally can't tell if it's fake or real. We're going to want to know what's reality. And I could see companies like Google and Apple actually putting the time and effort to say, hey, we put our real chips, real photo chips, real photo ID chips or whatever in that do this thing. And, now when you developers can build on it, whatever, you can build it into Facebook or Instagram or Twitter or whatever. And it can assign, hey, this was a real photo versus this wasn't. I can see there being a demand if people get kind of sick enough of like not knowing what's real and what's fake. It's just interesting, I guess. I've heard Vitalik. I've heard it said that Vitalik called ZK technology as impactful as the blockchain itself. I don't even know if that's true, for one. But would you agree with that? Like, would you say ZK is as impactful as the blockchain, or where would you put it in like the spectrum of like, hey, this is amazing, or this is like it's like kind of like a minor enhancement?
Yeah, so I might be in the minority among like ZK practitioners and people implementing ZK, where I actually think that like the clearest use case for ZK is in crypto and on the blockchain, because you don't have this problem where you have to like figure out how to like actually get sources of data into your zero knowledge proof so you can then prove things about it. Like with the blockchain, it's just permissionless. You can immediately plug in zero knowledge proofs for scaling or for privacy. And so I think it, like, at least in the short term, it's like a really, really important technology. But it's going, like, I think it's like zone of application is largely going to be focused on stuff in crypto.
What would you say? Okay, so I recently listened to a podcast on like shared sequencing. So like I know the optimistic rollups, they want to do kind of the ag layer type, hey, we can have this internet of chains, but they want to do it through shared sequencing. What is the difference between shared sequencing and what you guys are doing with the ag layer?
Yeah, so that's a good question. So this is like a really big misconception. The ag layer like is very complementary to shared sequencing and sort of vice versa, where like the ag layer provides this like guarantee of cryptographic safety. So it guarantees that like if you're submitting a synchronous bundle of transactions to a bunch of different chains, and you want to enforce that either all of those transactions execute successfully or none of them do, then the ag layer makes it so like we can have that guarantee and it can be enforced cryptographically. A shared sequencer would be like how you actually coordinate between chains. So how chains like decide which transactions to accept, which synchronous bundles to accept. And so I think from the optimistic case, and I think that a lot of people don't realize that this is true, like we don't have that guarantee of safety. And so users are trusting the shared sequencer to actually include bundles of transactions across all chains. They're actually like trusting the shared sequencer to like pass asynchronous messages between chains that are valid and consistent with the state of both the origin and the destination chain. And so I think that shared sequencing, like some of the shared sequencing proposals that I've seen for some of the optimistic rollup ecosystems they look much more like a single operator running a bunch of chains. And that's not the case for the ag layer. Like the ag layer is about providing this like foundational guarantee of safety and then letting chains navigate the trade-offs between like low latency and shared and decentralized and centralized sequencing and like different execution environments for themselves. And so I think it's much more sort of this like internet analogy where anyone can like set up a server and that server can be managed like however they choose, but they get integration into this shared environment. Whereas I think the shared sequencing proposals that I've seen for some of the optimistic ecosystems are more, let's trust all of these chains and let's trust a single shared sequencer to behave honestly across all of these chains. And I think that just comes with like a lot of drawbacks in terms of like how chains work, like scalability in the long run, like whether you can have heterogeneous execution environments. But I think it'll be interesting to see what those proposals end up looking like when they're implemented.
So how would you see them as complementary? Like how would they maybe work together? Like you have a bunch of changes with the shared sequencer, they plug into the ag layer. Now they can interact with the ag layer ecosystem. But when it comes to like the interactions between those shared chains, how would that work?
Yeah, so a good example is like Espresso.
Okay.
So they're building like a shared sequencer, but it's really like a marketplace for connecting chains with builders.
Okay.
And so it's a really, really nice fit for them to build on top of the ag layer because they get this stronger security guarantee where now like builders cannot misbehave and like include one transaction from a bundle on one chain, but let the other transaction on the other chain fail. So like when I talk about bundles, these are like sets of transactions that either must all execute successfully or none of them can be included on any chain. And so this is like a really easy example of this is like a burn mint transaction. Like if we're burning like 10 ETH on one chain and we're minting 10 ETH on another chain, it's really important that both of these things happen. So you shouldn't be able to like burn without getting your funds, and you shouldn't be able to mint without burning. And so the like synchronous composability can be generalized to like many, many different cases. But in the ag layer case, like we're just adding this guarantee of cryptographic safety, we're also allowing the shared sequencer to operate on a shared bridge. So there's no requirement that chains go like from L2 to L1 back to L2. They can take assets that are maybe L1 native assets, and they can exchange them seamlessly between L2 chains. But they don't. They never need to like post data to, or sorry, like post a transaction to L1, which would be really expensive. And so I would say that like the difference is that shared sequencing on the ag layer is just a much better experience for users, whereas shared sequencing on an optimistic rollup, I think, comes with a lot of like trust and safety guarantees. It really changes the trust and security assumptions of each individual optimistic rollup, because now, like before, if you think about our analogy of like people waiting in a room or people like waiting to enter the country, normally if you're transacting on a single optimistic rollup, you just need to monitor that optimistic rollup to make sure that no fraud occurred, that there were no invalid transactions. But now you need to monitor like all of the optimistic rollups that are connected to your optimistic rollups. And so you need to like run validators for like every single room that's connected to the original room that you were interested in. And so I think that this like really changes the game in terms of like what we were talking about earlier with the verifier's dilemma. And yeah, I just don't think that like, and we're going to write about this within Polygon, but I don't think that like optimistic rollups are a good case for having like a scalable multi-chain ecosystem that can kind of resemble the internet.
So, and I've heard this not just from you, I've heard this from multiple people, that kind of like optimistic rollups are maybe a great interim solution. Like they were like an in-between solution, but ultimately, you know, these things should convert into be ZK rollups, because that just makes a lot more sense. The glass room with people waiting 7 days is just a really great analogy of like, there's actually a lot of trust in that. Like you have to be optimistic. Somebody's going to catch it. And, you know, mostly people can do things right. And you kind of want to remove as many trust elements as you can from systems like this to make them as secure as possible. And so in your view, and in a lot of people's view, you know, these things should convert to ZK rollups. And then if there was like 5 ZK rollups, would they still use a shared sequencer? Would that still make sense? Or why would they use a shared sequencer if they're already on the ag layer?
Yeah, so the way that I would put it is that there are 2 ways for those rollups to interact. One is synchronous, so they this guarantee that like transactions will be executed at the same time across a bunch of chains, and the other way is asynchronous. And there's a higher cost for synchronous composability, and for certain applications, like you might not need synchronous composability. Like let's say you have like a gaming chain, and people just go there to like play games, get NFTs, and that's sort of like all of the interaction that happens on that chain. That chain probably doesn't need synchronous composability with like your DeFi chain, where institutional whales are like taking out loans and like entering and exiting big positions. You can still have a really good cross-chain experience between the gaming chain and a DeFi chain, but it would happen asynchronously. There might be like a little bit of lag, and you know, it might take like 1 to 2 seconds. But that's still, I think, a really good experience if you want to take your NFT from the gaming chain and then get liquidity for it on another chain. And so I think like one thing that's really important to understand about the ag layer is that chains can make these trade-offs where their users might not want to pay for synchronous composability with other like high traffic, high value chains, but they can still access the liquidity that's available on those chains just asynchronously. And so chains that want synchronous composability would opt in to shared sequencers. Like maybe in sort of the end game where we want to provide like a solution for like global finance, and we want an exchange that can like truly scale to like internet scale. We might have a bunch of different chains that all offer liquidity for like the ETH USDC pair, and those chains basically like are like auto scaling. So as we need more capacity, we add like another chain that provides ETH USDC liquidity. But we want to make it possible for all of these chains to basically be like immediately balancing. So we should allow for like arbitrageurs to immediately like enforce that the price for ETH USDC is consistent across all of these chains. And so there, it might actually be very helpful to have like synchronous composability because it gives better guarantees to arbitrageurs who are, you know, taking risk and dealing with like large amounts of capital and are more willing to pay like the marginal increase in fees for synchronous composability. So that's kind of the way I would look at it if that makes sense.
Okay, so the ag layer is asynchronous, and shared sequencing would be sequence. Is that right?
Well, so the way I would look at it is the ag layer is like the ag layer has two components. The part that Polygon is building is basically just like the cryptographic safety component. So it's the foundation that allows all of this stuff to happen safely. And then on top of that is what we call like emergent coordination mechanisms. And those could be shared sequencers, they could be relays, they could be builders. And so those are maintained and built by other community projects like Espresso and like different relay projects. And so that's what allows chains to coordinate. But the ag layer is what powers like the shared bridge, which is really, really important for unified liquidity. And it also provides like a safety guarantee where chains don't need to trust the shared sequencer or the relay or the builder to ensure that, you know, user funds are safe on their chain.
Got it. Okay, so people just plug into the ag layer. They could be doing asynchronous or synchronous. It doesn't matter. The difference between the two would be Mark was talking about like if a chain was like dealing with scalability issues, it could just spin up like if OKX is X1 is like, hey, we're overloaded. Cool, we're just going to spin up another chain. And these two chains are the same chain. They're both X1. Now, in that case, you'd want it to be synchronous. You want it to be everything to be in sync. So you might want to use the shared sequencer. But, you know, when it comes to two different chains interacting and, you know, there's two gaming chains and they don't like, they just do, they shoot in NFTs back and forth occasionally. Not really a big deal to be in sync on that level. So they might not use a shared sequencer. That's kind of the differences. Is that a good way to put it?
So I think that's like a good way to look at it. I think that when we conceptualize chains right now, we think of L2s as having like their own distinct branding and like their own communities. And it's like very apparent to a user when that user is like on Arbitrum or on like Polygon POS or on Optimism. And I think that's actually not the way that things will evolve in the future. I think they'll be more like servers where they provide capacity and they provide block space for users. But those users like don't fundamentally know like, oh, like I've bridged to Arbitrum and now I'm like in this ecosystem and in this community. It'll be like, oh, I want to access an application. That application happens to be on this particular chain, but I don't know that like I'm going to like this server or like this like corner of the internet. And I think that will be the same case for crypto, where like the sort of boundaries between chains are like very defined now. And inside the Polygon ecosystem, I think that they will become less defined in the future.
That makes sense. And you made me think of another way of putting it would be like Amazon. Amazon needs some more server capacity. They spin up another chain. They need that thing to be synchronous. They need that thing like it's in sync because it's like you're on Amazon. Where if you're going from Amazon to eBay, you know, those two things might not use a shared sequencer. Those things might be asynchronous, and that's okay. And that's a good way to maybe visualize it. And that's where something like Espresso might fit in and use the ag layer. They're going to be built in it. The ag layer is like the internet for them. That's how they connect to each other. But you know, they have different clients or whatever within the system that are using shared sequencing, and other people aren't using it. And it's just a big, cool internet of all these awesome blockchains. Last question is, I've heard some commentary on like a lot of people framing the ag layer. Originally this was a ZK stuff, but I do want to talk a couple of things about the ag layer. Framing the ag layer is like this really private, closed future for blockchains, where it's going to be like this private ecosystem of like shared chains, and then like they framed like other ecosystems as these open, permissionless gardens. But my view on the ag layer was that it actually was a pretty open and permissionless garden. There's so can you go into is there any taxes, any fees, or any drawbacks to joining the ag layer? Wouldn't it? From my view, it's why wouldn't everyone want to join it? But maybe I'm missing some drawbacks here.
No, that's my view too. If you look at how other ecosystems are developing in the L2 space, we can look at Optimism and Arbitrum. And in order to participate, in order to use Arbitrum's code and run an L3 or an L2, you need to pay 10 or 15% of sequencer revenue to the Arbitrum DAO. And you can only use this particular client that's maintained by Arbitrum. Same for Optimism. There's some revenue sharing agreement. It's 2.5% of profits or 15% of sequencer fees. And you're restricted. You have to follow Optimism governance. You have to use this specific version of the Optimism client. And so I think that the ag layer is a completely different approach to this. So we don't care what execution environment you use. We don't care what staking token you use, what gas token you use. There's no revenue sharing agreement. There's no restriction on chains that join the ag layer, because we think it's a real mistake to be value extractive at this point when we should be focused on growing the pie. Polygon has chains that will run in the ag layer. It's much better for the entire ag layer ecosystem if more chains join and bring economic value, whether that's economic value in terms of a cool DeFi primitive or an NFT mint or a cool game. It's purely a win-win for chains that are already in the ag layer ecosystem and these new chains, because the existing chains get their users get this economic value that's being brought by these new chains, and vice versa. These new chains get to immediately take advantage of existing liquidity and users and shared state. And so I think it's a really powerful model where if we are focused less on being restrictive and permissioned and extractive, we can build a much, much bigger ecosystem in the future. And I think that this is solving a real problem that exists for builders now, where I think a lot of builders want control over the environment in which their application runs. So you can see DYDX moved to Cosmos because they want to run on their own chain. They want to control every aspect of the user experience and be able to offer a better experience to their users. And if you think about what's required in the L2 space right now, if you're a really talented builder and you're building an NFT collection or a game or something in DeFi, you have to do that and you have to do it well. But that's not all you have to do. You also have to bootstrap liquidity and offer liquidity mining incentives and airdrops and play these crypto games in order to have a hope of succeeding for this actually cool thing that you built. And so the ag layer basically gets rid of that model. It says instead, you just focus on your game or your NFT collection or your DeFi primitive, and you can immediately tap into existing unified liquidity and all the Polygon users. All of that is available for you, as long as you build something that's truly great. And so I just think that this is a better model for crypto moving forward.
Yeah, and as you mentioned, and that was my understanding too, that it is an open permissionless. People were kind of painting it as if almost it's like Disneyland, right? It's a very permissioned environment where it's not. It's literally building on raw land. You come in here, you just got to plug in. You're hey, cool. I'm jumping in this ecosystem. You can build however you want. You don't even have to use from my understanding, Polygon CDK. You can actually just you could do whatever you want. You build your own L1, your own L2. It could be on the SVM, the EVM. You can IBC. Literally, however you want to build this, you can use Ethereum for DA, you can use Celestia for DA, you can, there is no rules really. It's just you plug into the ag layer, you build whatever you want. And you're not, there's no extractive taxes or or anything. It's just like literally there's no reason you wouldn't want to do this. There's no reason every single chain in the Cosmos ecosystem wouldn't want to just plug into the Ag layer. There's nothing holding anyone back. And it is really just this great public good that, anyone can plug into. You're going to tap into all this liquidity and, join the internet of blockchains. It's going to be amazing.
Yeah. Completely agree.
Awesome. Well, Brendan, it has been amazing having you on. You're really good at summarizing really complex things. Thank you for bearing with me on some of these analogies. You did make it way easier for me to understand. So I know you made it way easier for other people to understand as well.
Yeah, Jesse, thanks for having me. I think you did your part in a lot of those analogies. So I wouldn't, I would take some credit. I think we made some progress. But
as always, none of this was investment advice. You should always do your own research. Crypto is risky and you've got to act like an adult and own your own decisions. Remember, winners never quit, the path is always forward, and legends never die.